Hi there, welcome to Programming with C++. In this lesson, we're going to look at object-oriented programming. We're going to demonstrate some key concepts in this object-oriented programming concepts. So in this lesson, this is the outline of our lesson for the day. We're going to look at what is OOP concept, classes and instances of classes, class constructor, access specifier and encapsulation, inheritance, polymorphism, and abstraction. Because of the limited time we're going to look at the concepts, then we use code blocks ID to demonstrate one or two of the concepts. So without wasting much time, I'll just go deeper and start with the first on the agenda, which is what is OOP. OOP stands for Object-Oriented Programming. It's a programming paradigm or a programming methodology that makes use of objects. Objects just like real world objects. Objects like car, objects like pen, chair, table, computers, human object, animal object, house objects, table objects. So any physical thing that you can see in here will are seen as object. In object-oriented programming, we make use of the idea of objects. We represent every idea as an object. So object-oriented programming is a paradigm where everything is represented as objects, or we can say it's a methodology or paradigm that you make use of classes and objects in the design, in program design, or in the making of programs. We have key programming languages that makes use of object-oriented programming. I think the C is not quite. Sorry for the inclusion. I'll keep it quiet. So let me see. So C is not an example of. It's not entirely object-oriented, so I'll keep it off. Going back to my slide. Okay, so key or popular object-oriented programming languages are C++, Java, Python, PHP, C#, Ruby. Many examples of these languages employ the use of object-oriented concepts. So now, how do you model these objects? We make use of classes and objects. Classes to create the objects. So now, what is a class? So these are the concepts. Before we go to class, what's a class? These are the concepts we're going to look at under OOP, or these are the key concepts in OOP: the class, object, inheritance, polymorphism, abstraction, and encapsulation. Now, what is a class? A class is defined as a blueprint from which we can create an individual object. Class does not consume any space. Why does it? Why is that so? Because classes are blueprints, they are just templates. Okay, whenever we create a class, they are not allocated memory, but rather the object are located memory. Whenever we create an object out of a class, that's when memory is allocated for the object. A class has members, and the members are of two types. We call them data members and class member functions. Now, attributes and methods, which the data members are also called attributes. In the class member variable or class member functions are also called methods. So they are basically variables and functions that belongs to the class. These are often referred to as class members. So we say class data member and also class member function. How do you create a class? We create a class using the keyword class. And it's created above the intermediate in C++. Method are functions defined inside a class. We can also create a class outside in a different file. So using the include the class in the the main.cpp. Method of function defined inside the class. Another name for functions in class and called method, as we said. To access members, that includes method and variables or data members in a class, we need to use a dot separator. So you can see from the screen here that we have a class, the concept of a car class. This is a blueprint. If you want to make any car, the car should have this concept or this sort of idea. Should have methods, something that can cause a car to refuel, to get fuel, to set the speed, get speed, drive, okay, speed, stop. These are the behaviors of the car. Okay, this is a blueprint for the behaviors of any car that you want to make out of this class. Then we can set some attributes like the fuel, the engine type, the maximum speed, the color of the car. So this is what we call attributes or data members of the class. Now, so you can see that here we have a class side by side with objects. So you can see the class of the class, which is the blueprint. Using the class, we are able to make object out of it. So you can see that we have Mercedes object, BMW object, then Audi object. So what is an object? An object is any entity, just like in real world, that has state and behavior. The state is the attribute of the object, something that describes the object. And the behavior is what the object can do. For example, the chair, pen, table, keyboard, bike, house, these are all physical objects. Okay, if you take the pen, for instance, the pen has attributes like the color of the pen, the height of the pen, the size of the pen, the weight of the pen. Then what can the pen do? We can use the pen to write. Okay, if we take the table, we can sit on, we can put things on the table. The table has button legs, it has color, it has what wood type, the material made from. These are all attributes about the object. So an object can be defined as an instance of a class. We create objects using the class because classes are blueprints for making objects. An object contains an address and takes up some memory space. As I told you, indicated to you earlier that the classes do not take space in memory. They don't have, well, they are not allocated memory space, but rather the objects are allocated memory. During the creation of object from class, the CPU will allocate memory to store the object. Now, the process of creating an object is called instantiation. Okay, so now let's look at, okay, before we go to constructor, let's quickly move to our code blocks and demonstrate the creation of classes. So now let me see if I have shared the screen. So I want to share the entire screen. So now let's go to our ID. We're going to use the code blocks ID to demonstrate the concept of OOP concept using classes and objects. So the first thing in OOP is to be able to create a class. Then using the class, you are able to instantiate an object. Using the class, you are able to cause one class to inherit from another class, then demonstrate the polymorphism and abstraction. So the first thing that to do is to create the object, to create a class. So we're creating a class. Okay, so we use the keyword class to create the class. So keyword class, and the class is going to, we're going to create a car object, a car class. Okay, the car class is created like this. So now you can see that the class has been created using the keyword class in the name of the class. Now you can see that the first letter has been capitalized. This is a convention in the creation of a class name. The class name should be capitalized. Then you open the bracket and close the bracket. Now it's here that we can put the members of the class. Members of the class below. Okay. Now I told you the class members are grouped into two. We have data members and member functions, which are also called methods. So now let's model the car. What are some of the attributes we can find with a car, or we can model in a car? The first thing that we can do is maybe the car name. So it's going to be a string. So car name, the name of the car. You can say string color. Okay, then we can also say maybe the year. Okay, the year is going to be an integer. So say int year. Okay. So these three, we can use these three, even though we can model a lot of attributes on this scar, we're going to limit ourselves to these three attributes. So now, these are what we call the data members. So we just comment here again and say data members, okay? Remember data members of the class. Then let's look at the member function, class member function. So the class member functions below, or methods, also called methods below. So how do we put them below here? So what can we model about it? What kind of behavior can we model about it? We can just model drive, refuel, okay, get fuel. So now I told you the attributes are modeled using variables, and the behaviors are modeled using method or functions. So let's see. Now, as we say, I hope all of us are aware of or understand the concept of the functions, because before you, it's sorry to not say this in the beginning. You need to have a prerequisite before you can watch this video. You need to understand functions, variables, and other aspects of programming before we can look at the object-oriented programming. So I'm making this video with the idea that the one who's going to watch this understood the concept of functions, the concept of variables, the basics about programming. So we go ahead and create the method. So here we are going to get fuel, okay? So then this method is going to get the fuel. So, and it's going to take, okay, it's going to take two parameters here, the fuel. Okay, then we just say an amount, okay, amount of fuel. So using these two parameters, whenever we want to call the get fuel method to fuel the car, we use these parameters to fuel the car. Okay, then we can also model the car by driving. Okay, so drive, we need to get the speed. Okay, so you just say void drive. Okay, this method is going to accept a string, maybe an integer. Okay, int speed, we need to drive at a speed. Or instead of drive, you can say accelerate. Okay, when you accelerate, you are driving. Or for short, let's use a drive. Okay, so drive speed here. What do we want to do? You can say out. Okay, sorry, out the car is driving at a speed of, then we append the speed there. Okay, we end the line. So now when you save this, now we have the class members, which are of two types. The class data members and the class member functions, okay, which are also called methods. So now that we have created our class, let's see, okay, let's just run. If you run, nothing is going to happen because we have not what make use of the class. We don't create any object. It's just a blueprint. Nothing is going to show on the screen. Okay. Okay. So we have nothing in the int main. Okay. I think there's error here. String fuel int. Oh, sorry. The error is coming from here. It should be comma not semicolon. So let's save, and once go and run again without any error. You'll see a black screen, okay, showing nothing to us because we only created the class, which is a blueprint. If you want to make use of the class, you have to create an object of it. So you can see the black screen there. So the next thing that we have to do is to go to the int main, then create an object of the car class. So how do you create it? Just like how we create variable, the type of variable and the variable name. So similarly, an object and the type of object. So the car objects and the car object and the car object in the car class. Okay. So you just say car1. So using this car1, we are able to get members of, we are able to use members of the car class. But there is going to be an error here if we try to use any member of the class, because by default, all the members are declared private. Because we have not come to access specifiers, you wouldn't be able to understand what we call private, public, or this, which we, in short time, we're going to look at it here. So if I try to use the car, when I say car1 dot, you see all the members are indicated with the red one square here, indicating that they are private. So for instance, if I want to call the car name to set a value to it, I say car1 dot car name is equal to BMW. Okay, when I do this and save the file, then I can go here and say, okay, my see out. We are doing this knowing that there is going to be error because the members of the class are private. I want to indicate to you that it's not going to run. So you can say my first car is, see, then we can just say car1 dot car name. Okay, then we end the line. So when I save and run this, because of the error in access specifier, I will not be able. So it's telling you that, it's telling you here that there is error here. So when you go to if you check the error message, it says car name is private within the context. So as I told you, you should be patient. We will look at what is private, public. So to avoid this problem, we are going to indicate use this keyword here, public. And once you do that, the error will be fixed. And later on, I will show to you why we use public and why we are going to use private and protected. So you say my first car is BMW. Can you see that? So now that is how to create a car, a class. In this case, we have used a car class to demonstrate that. Then using the car class, we are able to create an object of the car class, which is car1. So with this, we can create more objects from the same blueprint. So if I want to make my second car, I can just say car2, okay, Then I'll say car2 dot car name is going to be Toyota. Okay, Toyota. Okay, Toyota. Okay, then we end here. So if I just want to run my, I want to display my second car, just say, instead of typing this, I'll just click here and Control D to make a copy and just say my second car is, then car2 dot name. Then I'm going to have the second car also displayed. So my first car is BMW, my second car is Toyota. So this is how to create a class and instantiate an object of the class. You cannot use the class without an object of it. Okay? You cannot use a class without an object of it. We create a class, we create the class, then instantiate. Instantiation means creating an object of the class. So now we have seen the members. These members, we cannot initialize or assign a value to them in the class. We can only assign them, we cannot directly assign a value to them, just like this. We say, okay, car name is equal to maybe Ferrari. Okay, when you do this thing and try to run it, it's going to be error. Okay, it's going to be error. Okay, okay. Though we didn't get error, and it doesn't make sense for you to assign value here because each time you create an object of a class, there is going to be a name for it. We want to have a specific name for any object. When you make any value, when you assign a value here, this is going to be the same name for this. So it doesn't make sense for you to assign a value here. Though in the previous versions of C++, we can assign, we couldn't assign. Now we are using the newest version, which is 20. It allows you to assign a value to a variable. And this is not the best way to assign the value. We can assign the values using the object so that the values will be specific to the objects. So this one way of assigning the value is to use the object name and call the data name or variable name and assign a value to it. Okay, another way of doing this is to use what we call constructor. So this brings us to the idea of constructor. What is a constructor? A constructor in C++ or in object-oriented programming is a special method of the class that is called automatically. It's invoked automatically anytime an object of the class is created, right? And it has the same name as the class. It doesn't have the return type because it doesn't return a value. It doesn't return a value. So let's look at how to demonstrate the constructor. Okay. And using the constructor, we can set the value for this, our data members. So now, just like any other methods, constructor is also a method, but it's a special method. So the name of the constructor is the name of the class. The name of what? The name of the class. So you can say car, it doesn't have a return type. So car, then you open this bracket here. So when you do this thing, we have created a constructor, but this constructor doesn't do anything. If we wanted to do something, we can, let me demonstrate to you the idea that the constructor is called automatically anytime an object is created. So here, if we create 5 objects, it will call 5 times. We create 2, it will be called 2 times. So you can just say this method, this constructor will be called automatically, called or invoked automatically. Right? So this is what we are talking about here. So when I save this, even without calling the constructor method. If I want to if I want to drive the car, I need to call the car method. So for instance, if I want to drive car one, so I have to say drive, let's say car one dot drive. Okay. And this drive takes what? Two parameters. So you can say, let me see what's the drive, and the car is driving at a speed of, okay, I'm going to add here, I can just say kilometers per hour. Okay, kilometers per hour. Let me use this. Okay, so save this. Now let's go back to our this. We have to supply two values. Okay, the constructor, the drive method takes one value, sorry. So you can just say 200 or 200, you can say 100 and 200. So anytime we call this, because it's a void method, we cannot use the cout to put it. So when I say run it, it says, okay, the constructor will be called automatically. The constructor will be called automatically. You see, because we created two object of the car class, the constructor has been called two times. Then the car is driving at a speed of 120 kilometers per hour. My first car is BMW, my second car is Toyota. So you see this. So to be able to call, if I close this, okay, then the comment, sorry, if I comment this, then I also comment these things. Okay, you can see that only one will be called, you can see only this constructor, only one statement. This constructor will be called automatically because there's only one constructor. There's only one object that has been created, and the car is driving at a speed of 120 kilometers. So if you want to be specific, we can just call the name of the car. How do that? Do that. You can say the name of the car. You can say my doing this. Then so I can say my, and then I'll just say car name. I'll use the my, whatever name you give it to it is driving. So let's say this. So now when you run it, okay, you just says my BMW is driving at a speed of 120 kilometers per hour. So anytime you call using the BMW objects, the car one object, you are able to call the method drive to drive the car for us. But we need to supply an argument, which is a value that is going to be needed in the making of the method. Okay, so without wasting time, let's continue with the setting of the values. So I'll just uncomment this, also. Then inside the uncomment this also. Then inside the constructor, I'll kick this. I don't need this. I'm only interested in assigning a value using the constructor here. So because we want to assign a value, the constructor must take a parameter. So how many parameters? We are going to assign 3 values. So to take 3 parameters, we say string cn for the car name. Then we say string color cl for the color of the car. And then int y r for the year. So here, so now whatever value passed to the constructor is going to be assigned to the data members. So the first one, let's say car name is equal to cn. Then say color is going to be assigned to cl. Then here is going to be equal to the y. So now, no need to be able, no need to use these things. And we need to say, okay, can is equal to this. No need to assign them this way. So to be able to assign this way, you assign them. What do you do? We really use this. So you can just see in the creation of the object, we pass the value. So the car name is BMW, okay? And everything will be fine. The color of the car is going to be white BMW. Then the model is going to be 2021. Okay, and the car two also is going to be Toyota, Toyota. Then the color of the Toyota is black. Okay. Then the model is 2022. So now we have been able to assign the values, and with this, the program will work fine because the values are there already, and there will not be any error. So you see, my BMW is driving at a speed of 120 kilometers per hour. My first car is BMW. My second car is Toyota. So I will just copy this and put this below. Okay. So again, you can just say car two. If you want to drive the car, you say car two dot drive and supply um data 1890. Okay. So and this one is going to run again. So it's going to say my first car is BMW, my second car is Toyota. My BMW is driving at a speed of 120 kilometers per hour. My Toyota is driving at a speed of 90 kilometers per hour. So this is how to demonstrate a constructor. And the function of a constructor is to initialize values, to call methods that needs to be called immediately the program starts. And we have many types of constructors. We can overload the constructor when we have more than one constructor. The function, the method signature should be different. Okay, so when you have more than one constructor with different signature, we say the constructor has been overloaded. Okay, so for instance, if I go to the car class, then I make another constructor here. You can just say car, okay, and this constructor, this one doesn't take anything. Because it doesn't take anything, you can say that the constructor has what been overloaded. So anytime we create a class without what making a constructor, without passing the value, this one will pick us the constructor to be called. Okay, so that is what we call constructor overloading. We have constructor with a parameter, constructor without a parameter. You can have more than one constructor in any class. Then if you don't specify a constructor method, there is what we call default constructor. That one will be automatically called without the making of the program. Okay, so I think we have seen how to assign values to the data members using the objects, then also using the constructor. Now, the third method, which is the best way to do that, is to use what we call getters and setters. The getters will be used, the setters will be used to set values for the data members, and the getters are going to be used to get the values. So to avoid, I will just comment on this, Okay, just go to edit, then choose comment, then these are going to be commented. So anytime I'm calling this, I don't need to wait. Just comment this one. Okay. Then I'll only create the car, so car one. Okay. Like this. And the car two also. I'll just also comment this and create my car two. This is car two. Okay. So once this. Now how do you set the values? If you run these things, okay. Now when I save this and I run this, we are going to get empty. You are going to get empty values. You say my first car is dash, my second car empty. My dash is driving at a speed of, because we have not set the values. Okay, we have not used the method, the object to set the values. We have also not used the constructor to set the values. So we are going to use what we call the setters and getters to do that. The setters are special methods that are used to set values for the data members, and the getters are used to get the values for the data members. So how do you do that? They are also going to be declared public here. Okay, they are going to be declared public. I'm going to put them just here, just below the constructor. So I just say setter methods below. Okay, the setter methods are used to set the values. So the first value, the first data member we are going to set is the name. So you can just say void, because they are only setting values. We use the void keyword. You can say set car name. Okay. Then we need a parameter type string. So let's say CR or CN. Then using the parameter, whatever value supplied to the set car name is going to be passed to this, the car name. So you can just say car name, okay, it's going to be CN, right? So anytime you set, okay, we'll do the setters for all the data members, then we'll do the getters separately. So now, using the same idea, we can set the color and copy, instead of typing, copy and paste below here. Where this is set color. So we're going to set the color of the car, and this is going to be C color. Here, this is going to be color is going to be equal to what? CL. So anytime we call the color, we set the color color, it is going to set whatever value we pass to it to the color name. We will do for the set age, set year. So here, because it's an integer, so let's say int y and so here the year of the car, and let's say y and again. So now that we have we have made the setters, let's make the getters. We just say getter methods below, okay. Right? So what are the getter methods? So now all the get methods, they are methods, they are functions with a return type because they are returning a value. So we have to indicate the return type of the value that is going to be returned by that method. So first of all, we get the name. So the name is a string. So we say string get name, okay, get scanning, right? And since it's returning, we don't need any parameter. So we only say return scanning. So anytime anyone calls get scanning using any method, we return the scanning for the person. So I will just copy again, then edit. I don't need to type everything. So we just get the color and we return the color. Okay. Then we also get the EN, get the EN. Get the ear and return here. Okay, so with this, it's now we can go back to our int main and call the setters and get setters to set the value. So for car1, we just say setting values for the car1, okay? So using the for car1, using settings. So you just say car1 dot sets car name. Okay, what's the name of the car? It's going to be BMW. So the car name has been set. Then we set the color of the first car again. This is set color name. The color is going to be white BMW. Okay. Again, we set the year. So year dot sets the year. Set year, then we supply the year is 2020. Okay, so we are now done with the first. Then we can also set for the second, set values, setting values for the car 2. Okay, setting values for the car 2. Setting values for the car 2 using the get this settings already. Okay, so I'll copy all this thing and just change the I'll copy paste it below here. So we have car2 is to the left. Okay, then the color of the car is black. Then the year is 2021. So now we have now used, if you now call, if you run this application, you will see everything. Okay. Now let's see. String. Okay. There is error here. It says year from int to. Okay. I didn't change this one to integer. Sorry, I should change it to integer. Okay. So let's go back to. So let's see the new errors. So let's save this, run it again. Then we are going to say my first car is BMW because we have used the set car name to set the value. My second car is Toyota, the same thing as we had before. So we can use 3 means to set values for the data members in a class. 1, using the object name. 2, using the constructor. 3, using the setters and getters. But the setters and getters, okay, the setters and getters are key elements that are used in encapsulation. So this one brings us to the idea of what we call encapsulation. Encapsulation means hiding data, hiding data so that you make it available to the appropriate time it's needed, okay, or appropriate method or appropriate call. Okay, so encapsulation is just hiding the data, and this is done to ensure security of the code and security of the application. So how do you implement encapsulation? Encapsulation, the idea of encapsulation is to make all the data members private and make all the member functions public. So using the public member functions, we are able to access the private members. So what can we do? What are we going to do here? So we just change the keyword from private to from public to private. Then just below, okay, here we just declare all the methods as public. Now I'll explain what we mean by public. Okay, so this public, private, and protected are what we call access specifiers. Okay, so we say access specifiers. Access specifiers are used to specify the access method, the way to access the members of the class. Okay, access specifiers. Specifiers. Okay, then we have private, public, and protected. So let me explain these three keywords. When we set any member of a class to be public, it means that it's going to be accessible in both the class and outside the class. Okay. Then when we set it to be private, it's going to be accessible only within the class, but not outside the class. Then we are protected when we set the members of the class to be protected. It means that they are going to be accessible within the class and inaccessible outside the class, but accessible in inherited classes. Later on, we will see this. So in an encapsulation, the idea of encapsulation is to make all the data members private and make the member functions or methods public, so that using the public method, we are able to access the private data members. So you can see that when I save this, nothing is going to change. There's not going to be any error. Okay, what is the error here? The error is coming from here because we have used the setters and getters. So we have to say, instead of, because we have not set the value, there's going to be error here. So we have to say set scanning. Sorry, we have to get the scanning. So get car, get scanning will get the scanning for us. And here also we just say get so using the method, we use the get car name to get the name of the car instead of just calling the method directly, calling the variable directly, which is without security. To ensure security, we use methods to call the data members. So now with this rectified or this error fixed, we can just click and run, and there's going to be the same thing for us. So say my first car is BMW, the same car is this. Okay, that's okay. I hope the concept of access specifier is explained. Encapsulation is also explained. Now let's look at what we call inheritance. What is inheritance? Inheritance is a way. Inheritance is a way to make members of one class available to another class. Inheritance is just like our, just like biological inheritance, where a child inherits from their parents. Okay, so similarly, inheritance, when a class inherits from another class, the class that inherits is called a derived class or subclass. In the class that we inherit from is called the superclass or base class. So let's implement this, then we just call it a day. So how do you do that? We're going to create another class. That class is going to be maybe vehicle class. Okay, so we go just build above this one, make another class. Let's say vehicle. Okay. Okay, then this vehicle class is created. So we are going to have, you can just say private, okay, or make it, if you want to make it private, you can just say string model. Okay, it's going to have a model. Then you can also say string, maybe what can we add again? Engine type, okay, engine type. Okay, so this, in this class we have all of this. So how do you do this? we need to what? Make we can make another public method here. What can we add to the vehicle? We can say um, what do we want to do here? Okay. Okay, we can just say clear windscreen. Okay, windscreen clear. We can just avoid wind, winds. So windscreen. So anytime we call this method, what it does is that it only clear the windscreen for the see on it. Okay. Now, since we did just demonstrating a concept, we only be using C out to demonstrate something. And then, okay, the windscreen is being cleaned. Okay. So now we have another class. Okay. We have another class called vehicle. In this vehicle class, okay, we want to make the car class to inherit from the vehicle class. So how do you do that? We just use the colon here, then just say public vehicle. When you say public vehicle, it means that the car class is going to have access to members of the vehicle class, even though we don't have them in the car class. So when I go back to this, when I go to the main, if I go into the, when I go to the, when I go to the main, I want to create, if I say car, or just using the car one method, when I click on dot, you see that all the methods that have not been declared in the car class are now within what? That are declared in the vehicle class are now available to us in the car class also, because we have asked the car class to inherit from the vehicle class. So that's what we call inheritance. Because of time, we're going to limit ourselves to this. Later on, maybe we want to go deeper, part 2, part 3. We will go deeper on how to inherit a class with the constructor and the rest. So this is what we call inheritance. So inheritance is a way, it's a concept in OOP that allows one class to inherit the features or methods or members of another class. We have different types of inheritance. We have multi-level inheritance. Then we have multiple inheritance. Multiple inheritance where one class inherits more than one class. So class A inherits from class B and C. Okay, so when class A is having multiple parents, so we say multiple inheritance. We have multi-level inheritance where class A inherits from class B, that also inherits from class C. So indirectly, class A will inherit the members of class C. That's what's called multi-level inheritance. So without spending time, we will just go to our PPT and look at what is inheritance. We have seen access specifier, I explained already. Encapsulation, I've also explained how to make it. Inheritance, a feature or concept in OOP, in which new classes are created from existing classes. The new class created is called drive class or child class, and the existing class is known as the base class or parent class. The drive class is the drive class now is said to be inherited from the base class. Okay, so this is the concept explained. Then this is an example of I even have example. So this is the base class. So my class with all this content, then we have drive class, my child, public what my class. Then if we want to use them, we can also have a grandchild. So the grandchild is going to inherit from my child. Okay, so let's look at the polymorphism. We will not demonstrate this practically. We just explain to you because we have limited time. Okay. Polymorphism is the process of using same method name by multiple classes and redefines method for the derived classes. So in this, okay, in this, if we go here, if we go to this class, if we go to the vehicle class, or maybe in the car class, we see we have a method called drive. Okay, we can also have another method here in the vehicle class. In that method, it's going to can say, okay, void drive. Okay, so this drive, we can just make this method, this drive method. We only declare it, but we are not using, okay, we are not doing anything there. So you just say see out, right? And just say driving. We are only driving a vehicle without what indicating how we drive it. So when we run this, so you see that we have a drive class here, but the same class name is declared also in the car class, but with a parameter that indicate how the car drives. So when we save this, we go to the using the car one or car two objects. When I click here, you see that the drive, we have two of them. We have first one and second one. They are both void, but one has a parameter and one another doesn't have parameter. Okay, so that is what we call polymorphism. For want of time, we will just leave this. Then another key concept in OOP is what we call abstraction. Abstraction or data abstraction is a programming and design technique that rely on the separation of interface and implementation. In data abstraction, we provide only essential information about the data to the outside world and hiding the background detail or implementation. I'll use this real life example. If we take a car, for instance, the car has gotten the accelerator, the brake. Okay, let's use these two items in the car. The accelerator. As a driver using the car, you only know what the accelerator do, and that's sorry. And you only know what the brake does. But how the brake is applied, it's none of your business. It's a detail that has been hidden from you. You only need to know how to drive. You only need to know how to apply the brake. You just press the pedal, the brake pedal, and the car will come to halt. If you want to drive or you want to accelerate, you press the accelerator, then the car will start accelerating and driving. But as to how, whatever happens behind the scene, whenever you press the accelerator, you don't know it as the driver. So in this case, we have done abstraction with this kind of idea. Abstraction is done to reduce complexity to the users. Instead of you to be dealing with how the functionality, you deal with how to use. You only need to know how to use. So in the car example, for instance, you only need to know how to drive by pressing the car accelerator, applying the brake, changing reverse and these things. But the principle behind changing the gears, changing to drive, changing to parking, you don't know the principle behind it. That's what we call abstraction. So now the last thing we'll look at under the OOP is the benefit of OOP. Why do we use object-oriented programming? So let's look at some of this. It has its own benefit and disadvantage, but we look at benefits here. We have many benefits we can mention, but the key benefit we can talk about here is that systems developed using the OOP concept can be maintained easily due to modularity of the code. Because when you use OOP, the code becomes modular. Things are arranged very well in modules. Okay. When you want to maintain the code, it becomes easy for you. Then they provide code reusability. Reusability is ability to use code without creating it. And this reduce what we call data redundancy. Data redundancy is when you reproduce multiple codes, same code, in different places of your program, which is going to increase the number of lines of your code. So through OOP, we only need to call method without redefining what they do. So they provide code usability through inheritance. Okay, if like example of the drive method in the car in the vehicle. Okay, if we want to drive, okay, if we want to drive using, if there is big, okay, using the clear windscreen method, we don't need to declare windscreen method in the car class because it has already been declared in the vehicle class, and we have inherited the vehicle class. So hence, we have limited number of code we could have created in the car class. Then we have scalability and extendability. They can be easily upgraded to add new functionalities without starting from scratch. Okay. Using OOP, programs created using OOP are scalable and extendable. Okay, we can easily upgrade a program to add new functionality without starting from scratch. Then another benefit of OOP is that the principle of data hiding helps in building very secure systems. Using encapsulation, we are able to build a very secure systems without any problem. More example, prevent data redundancy. Since data can be used in multiple classes, data redundancy is when data is repeated unnecessarily, which can lead to data inconsistencies, storage problems, and other issues. Debugging is easier because codes are organized better in OOP and ability to find and fix errors. So these are some of the benefits we can mention of object-oriented programming. And without much ado, I'm going to pause here. We want to thank you for taking your time to watch my demonstration, explanation. In the course of making this demonstration, I've made a lot of mistakes. It is due to the fact that I'm inherited to present to make this demonstration. I hope my errors will be ignored. Thank you for watching. Okay, I didn't mention my name when I was at the beginning. My name is Tahiru. I'm a computer science teacher. I teach AP computer science. I also teach AP computer science A, AP communication principles. I've taught IDC, SC computer science. Then I teach a lot of programming languages, Java, C++, Python. I'm an expert in web development or design websites from scratch using C++. We're using HTML5, CSS, and JavaScript. And I've learned to use many frames in designing of websites like React, JS, which many more. So without, I want to thank you for listening to me, for taking time to watch my video. Thank you very much.